So in this video, continuing on the theme of circle area and circumference, we'll be focusing on arc length and sector area. Now there will be some notes in the description below, and I'll also include a copy of the example questions which this video goes through to try and get an understanding of what questions of arc length and sector area you can expect in classwork, homework or in exams. Now before we get started, it's really important that with any parts of a circle that you understand the difference between the two main things. So here we've got a sector. Now a sector is like a slice of pizza, but the most important aspect of a sector is knowing its definition, which is that it's part or proportion of the circle's area. Now we're moving on to the arc. Well, the arc is like the crust of a pizza slice, but as I said, the most important aspect is that it's part or proportion of the circle's circumference. Now one of the reasons why I highlight those particular aspects is it's going to be useful for when remembering the formula of these two things respectively. So the two formulas that you need to know is that the arc length is theta over 360 multiplied by 2 pi r, and the sector area is theta over 360 times pi r squared. Now I know these are another set of formulas that you need to know in maths, which again adds to your things for you to revise, but you can be a little bit smart in terms of how you revise this. Now what you should notice in both the arc length and the sector area formula is that both contain this theta over 360. Now theta is just the angle size of the arc or the sector that the arc or the sector is involved with, and that appears in both these two formulas. Now this part of the arc length, which is 2 pi r, is the formula that represents the circumference of the circle. Now typically, when you're remembering the circumference of a circle, you think of pi times diameter or d times pi, whichever floats your boat. But we're here because a sector involves a radius. That's why we use the formula of 2 pi r. So as long as you remember that the arc length is the part of the circumference, and you can write the circumference of a circle as 2 pi r, then really the only thing you've got to remember is theta over 360. And likewise with the sector area formula, that this part here is the area of the circle. So this theta over 360 is just basically a proportion of the circle that the sector represents of the entire circle. So again, to help your revision, if you just remember that you've got theta over 360, and for the arc length using the formula for the circumference, hopefully you're remembering it's 2 pi r, and for the sector area, that's part of the area of the full circle, and the area of the circle is pi r squared, then remembering these two formulas is going to be a lot easier for you to use. And again, I strongly recommend that in your notes you do make a copy of these two formulas and also the diagram as well. So let's start by going through some examples. So here it says find the area of each of the following sectors, and we're going to write our answers in terms of pi and 2 decimal places. Now what is important is that you are reading the questions, because these questions both for arc length and sector area are very, very similar. So it's not one of these types of questions that you can just see the diagram and think, oh right, yeah, I know what to do, because it is important you understand what it is you're trying to find. Now in this particular question we're asked to find the area of each of the sectors, and that when writing our answers, I'm going to show you how you can write your answers in terms of pi, which tends to appear on a non-calculator paper, and we're going to also use our calculators to give our answer to 2 decimal places. So these types of questions can come up on a non-calculator paper, but what you find is that the numbers involved will be relatively easy for you to substitute into the formula and then also simplify. Now before we get started, let's first of all work out or write down the area of a sector formula, which is theta over 360 multiplied by pi r squared. So this is the formula that I'm going to be using for these 4 examples. So the first things first, let's get this started. So again, if you haven't written the formula, I would always start by writing the formula down. So here we've got that r equals 11, and our angle, although it's not mentioned, is 90 degrees. So substituting a into our formula, so we're working out the area. So here we've got 90 over 360 multiplied by pi times 11 squared. Now with this, what we want to try and do is simplify where possible. So 90 over 360 is basically a quarter. We simplify that, times by pi times by an 11 squared, which is 121. Now if this was on a non-calculator paper, then all I'm going to do here is join my 2 sort of numerical values. So I'm going to combine these 2 things here. So I'm going to do 1 times 121 over 4 pi, which gives me an answer of 121 over 4 pi. And there is my answer, centimetres. Don't forget the units in terms of pi. So this here is my answer in terms of pi. Now if you enter this formula into a calculator, then you press equals, and your calculator, depending on if it's one of the Casio ones, will probably give you your answer in terms of pi first. So what you then need to do is press the sort of SD button if you have got one of those calculators. And so if I just simply type that into my calculator, I get an answer of 95.03, and it's centimeters, and that is to 2 decimal places. And there is my final answer for that. So moving on to question 2. So again, question 2, here we've got more complicated angle. So again, the area is going to be equal to 47 over 360 multiplied by pi times 8 squared. So here, to work this out, all I'm going to do is 47 over 360, which is not going to simplify, times by pi times by 64. Now if I was to work this out in terms of pi, then I would do 64 times 47 over 360 times pi. And now what I then need to do is work out what 64 times 47 is going to be. Now it's unlikely that this type of question would come up on a non-calculated paper, because again it's going to be a little bit confusing. But generally speaking, if I was to use a calculator, then basically all I would do is I would type this all into my calculator. So then doing just that, so 47 over 360. Now if your calculator has got a fraction button, then I strongly would recommend that you do use it, times 64 gives me an answer of, so in terms of pi, this answer would be, so let me just get back to that blue pen just to keep it consistent. So my answer in terms of pi would be 376, which is simplified over 45 pi, and that's in centimeters. Or if I was to do it to 2 decimal places, it would be 26.425 centimeters, and that's to 2 decimal places. And there is my final answer. So now moving on to question 3. So again, using the formula, I've got A equals, and it's the angle, which is 124 over 360 multiplied by pi times the radius squared. So again, if I was going to do this on non-calculator, then what I would have to do is try and simplify what 124 over 360 is, which simplifies to give me 31 over 90, but I'm not going to worry about that just yet. And so from this, what I'll then need to do is do 124 times 144 over 360 times pi, and that equals 248 over 5 pi, and working that out as a decimal gives me an answer of 155.82, and that's going to be centimeters squared. So this is the answer in terms of pi, and this is the decimal answer of that particular question. So moving on to question 4. So again, working out the area. So my components are that theta equals 279 and that r equals 9. So substituting numbers in, I've got 279 over 360 multiplied by pi times 9 squared. So here I've got 279 over 360 multiplied by pi multiplied by 81. And again, if I type that straight into my calculator, I get an answer of 2511 over 40 pi. So that's my answer in terms of pi. But as a decimal gives me 197.21 centimeter squared. And there we go. So let's have a look at these two equations here. So now with this particular question, here we've been given the external or the exterior angle of the sector, and so what I need to do first is first of all work out what this angle here is going to be. Now if that's going to be 311, then all I need to do is take it away from 360, which gives me 49 degrees. So with question 5, the angle is going to be 49 over 360 multiplied by pi times 16 squared. And again, if I just simply type that into my calculator, and as I mentioned, if you've got a fraction button, I certainly would use it, but make sure that your answer looks exactly, what you're typing in on your calculator looks exactly on how I've written it on the screen. And your calculator, if I press equals, gives me 1568 over 45 pi, and that's going to be in millimeters. Or I could give my answer in terms of a decimal number, which is 109.47 millimeters squared to 2 decimal places. So moving on to question 6. So again, the first thing I want to do is work out what this angle here is. So all I'm going to do to work out the angle, I just take it away from 360, which gives me 151 degrees. So working this out, it's going to be 151 over 360 multiplied by pi times 350 squared. Now this is going to give me a huge number, but again, just typing that straight into my calculator, 151 over 360 multiplied by pi multiplied by 350 squared gives me an answer of, now this is what my calculator is telling me, it's 9.24875 over 18 pi, and that's going to be in meter squared. But writing that as a decimal is going to give me 161421.14 square meters, and that's to 2 decimal places. Now at an extension level, you may have to look at some reverse questions. So with reverse questions, this is where you're given the area of the sector and you need to either work out what the angle is or what the radius is. Now looking at question 7, so again what I'm going to do is I'm just going to write down what the formula is. So here I've got theta over 360 multiplied by pi times r squared. Now in question 7, so let's just start by writing that down. Question 7, I know that a equals 60 and theta equals 68 and r equals x. So what I'm going to do is I'm going to substitute these numbers into the formula. So what I've got is I've got 68 over 360 multiplied by pi times r squared, and that equals 60 centimeters squared. So what I'm going to do is the opposite of multiplying by 68 over 360 times pi is to divide by that. So what I'm going to do is I'm going to divide by 68 over 360 multiplied by pi, and so if I just type that into my calculator, I get r squared equals, so 68 over 360 pi equals, and then 60 divided by the answer gives me r squared as being 101.110199. Now a common question is, should I write down all the digits on my calculator? Well, I would say yes. So r equals, now once you've got that, all I then need to do is square root. Now you can either write down the number, which is 1101 blah blah blah, or what you could do is square root and then press the answer function. And if you do that correctly, you should have the correct answer of 10.06, and it's in centimeters, and that's to 2 decimal places. Now how do I know it's in centimeters? Because my area is in centimeters squared. Now moving on to question 8. Now again I'm going to use the formula, but this time I notice that the area is given to me in terms of pi, which is absolutely fine. So substitute numbers in, I get 120. Well, I don't, because that's not the angle of the sector. So again, how these mistakes are easily done. So this angle here is 240, so it's going to be 240 over 360 multiplied by pi times, and the radius, which is what I don't know, which is y, equals, and it's going to be 48 pi. Now, because I've got pi on both sides, what I can do is simply cancel the two things out, which is absolutely fine. So here I've got 240 over 360 multiplied by y equals 48. Now, treating this little fraction part as a single thing, and that's been multiplied by y, that's what I want to get rid of. So the opposite of multiplying by 240 over 360 is to divide by 240 divided by 360. So if I do 48 divided by 360, and again, just one thing I forgot to write down, that should be y squared. like so. So here I've got y squared equals, and that's going to be 48 divided by 240 divided by 360, and that gives me an answer of 72. Now I need to work out what y is, so therefore y equals the square root of 72, which gives me the answer of 8.49, and that's going to be in meters to 2 decimal places, and there is my final answer. So it's always wary just practicing reverse questions. Again, there'll be more high level questions, but again, if you can practice these ones and you can do them, then you shouldn't be faced by any other sort of question. So now let's move on to arc length. So in these questions we're asked to work out the arc length of the following. So this, we're not working out the perimeter of the whole shape. We'll come on to those questions in due course. So all I'm working out is what this length here is. And for question 2 it's just this pink length here. So to work out what that length is, so for question 1, so again working out the formula, so the arc length is equal to theta over 360 multiplied by 2 times pi times r. So working this out for question 1, I know that r equals 15 and theta equals 90. So all I'm going to do is going to substitute those numbers in. So I've got 90 over 360 multiplied by 2 times pi times 15. Now what I should recognise is that 90 over 360, looking at the diagram, is just a quarter. So I've got a quarter times 2 times 15, which is 30, times pi. Now just because I've moved the 15 over and swapped that in terms of places with with pi, that's not a problem. So here what I can do is I can just simply write this as 30 over 4 pi, and that's my answer in terms of pi, and that's going to be in centimeters. Now if I wanted to write that as a decimal, then all I need to do is to simply type that into my calculator, and that gives me an answer of 15 over 2, or it should be 15 over 2 pi, simplifying the fraction, or writing it as a decimal gives me an answer of 23.56, and that's centimeters, and there is my final answer to 2 decimal places. So now working with question 2, again let's use a different colour. So for question 2 I've got theta equals, and let's just get rid of that line because I don't know where I've put that. So theta equals 22 and r equals 7. So substituting it into the formula, I get 22 over 360 multiplied by 2 times pi times 7. So again, trying to simplify this, I get 22 times and 2 times 7, which is 14, over 360, and that's being multiplied by pi. And all I've done is just shuffle the numbers around. So 22 times 14 is 308 over 360 pi, which simplifies, which and it will because I've got even numbers. So here I can divide both numbers by 4, so I get 77 over 90 pi, and that's again in centimeters. Now again, if I want to do that into as a decimal to 2 decimal places, it gives me an answer of 2.69 centimeters, and that's to 2 decimal places. And there we go. Now you will find, using your common sense, that if theta is big, then you'd expect your answer to be relatively large. If theta is small, you would expect your answer to be small, because like I said, just use your common sense of the sort of length of the actual arc that you are actually working with. So just like before, let's have a look at some reverse questions. So here what we're doing is, now with these lengths here, the arc length is just representing what this length here is. So again, we're not moving on to this perimeter, which is what we will do in due course. So looking at question 3, so let's just get an appropriate colour. So with question 3, I'm going to write down the formula again. So I've got the length equals theta over 360 times 2 times pi times r. Now in question 3, I've got that r equals 9. Theta is what I don't know, so I'm just going to call that theta, and L is 26. So substituting these numbers in, what I get is theta over 360 multiplied by 2 times pi times 9, and that equals 26. So what I'm going to do first is I'm going to take all of this over to the other side. So the opposite of multiplying by 2 pi times 9 is to divide by 2 times pi times 9. So if I type that into my calculator, of 26 divided by 2 times pi times 9, I get an answer of 0.459780947. Now what I now need to do is I need to get theta by itself. So what's happening to theta is being divided by 360. So the opposite would be to times by 360. So theta equals that number times by 360, which gives me an answer of 165.52 degrees, and that's to 2 decimal places. Now again, using my common sense, does that answer look correct? Well, yes, because this represents an obtuse angle, and this angle here is clearly obtuse. Now we're moving on to question 4. It's important that I note a couple of things. So the first thing I need to note is that the arc length is given to me in terms of pi. So this arc length here is equal to 2 pi. Now the question's also asking me to find is this angle here. So it's not actually the angle in the actual sector, it's this angle here, but I need to find out what this angle here is first. So looking at the components, I know that L is equal to 2 pi, I know that theta is equal to theta, and I know that R is equal to 21.3. So substituting numbers in, I get theta over 360 multiplied by 2 times pi times 21.3, and that all equals 2 pi. Now because I've got pi on both sides, I can simply cancel those out, so I'm just dealing with numbers. So here what I've got is I've got theta over 360 times, and it's going to be 2 times 41.3, which is 42.6, and that all equals 2. So first thing I'm going to do is I'm going to take the 42.6 over to the side by dividing, so that disappears. So what I'm left with is theta over 360 equals 2 divided by 42.5, so 2 divided by 42.6 equals, and it gives me a long decimal number, so I'm going to leave it as a fraction, which gives me 10 over 213. Now that, as a decimal, if you've not got one of the Casio calculators, is 0.04694883, and it continues on forever. Now, what I need to try and do is get theta by itself, so what I need to do is get rid of this 360. What's the 360 doing to theta? It's dividing, so to get rid of it, to take it to the side, I need to multiply it by 360. So theta equals either 10 over 213 times 360, or I can do this decimal number times 360. But basically, if you've got the answer already on your calculator, just times the answer by 360, and you get the answer of 16.9. Now, the problem we need to remember is that this angle here is 16.9, but the angle that we need to work out is this angle here. So to work out what theta is, I need to do 360 take away by 16.9, or whatever that decimal is, which is 9.01408 blah blah blah. So do 360 minus that answer, and it gives me a final answer of 343.1, or 0, actually 1 degree, and there is my final answer. Now when working out the perimeter, it's important that you recognise what the perimeter actually is, and it's the distance around the whole entire shape. So when you have got questions involving arcs and sectors that ask you to work out the perimeters, it's also always important that you include the straight edges as well. So if we take this first example, that we can see this as certain sort of components as a perimeter of this shape. So this perimeter is this straight edge here, this straight edge here, and then what we've also got is the major arc, which is that distance there. So first things first, if I deal with the arc first, so what we've got is here we've got that this angle here is going to be 270. So it's going to be 270 over 360 multiplied by 2 times pi times the radius, which in this case is 2. So from this, what we've got is we've got 3/4 times 4 times pi, which gives me 3 pi altogether. So that yellow distance there is represented by 3 pi. Then what I've then also got to do is I've got to add the two straight edges, which is going to be plus 2 plus another 2. So typing this in terms of pi, which in this case I can work out, so that's going to be 3 pi plus 4 meters, and that would be the final answer. Or I could write it in terms of decimals, in which all I'd have to do is type that into my calculator, which gives me 3 pi plus 4, which gives me an answer of 13.42, and that's going to be meters to 2 decimal places. So if I look at now, move on to question 2, I can see here that I've got this straight edge, I've got this straight edge, I've got this straight edge, or let's just do that in a different colour, and let's go for green. So I've got this straight edge, and I've also got this edge here. And then I've also got the two arcs, which in this case we know are both the same. As 2 are all of those straight lines, they're all 16 millimeters long. So to first of all work out what the arc is going to be, well, that's going to be 42 over 360 multiplied by 2 times pi times 16. So if I type that all into my calculator, 42 times 2 times 16 gives me 1344 over 360 pi, which simplifies to give me 56 over 15 pi. And that gives me what the arc lengths of those two are going to be, and I've got 2 of those. So to work out the perimeter of this particular shape, so P equals, it's going to be 56 over 15 pi plus 16 plus 16 plus 16 plus 16 plus another arc of same length. And what I then need to do is type that all into my calculator. So 56 divided by 15 times 2 plus 32 plus 32 gives me a final answer of 87.46, and it's going to be millimeters, and there is my final answer for that one. Then moving on to question 3, so again looking at the different components, so I've got this arc here that I need to work out, then I've got this straight edge, then I've got this arc here, and then I've also got this long straight edge. Now in terms of the components that I know, well, I know that this here is going to be 2, because that's going to be the difference between the two sort of lengths that I've been given, so that's 2 centimeters. And I know that the bottom line is 10 centimeters, and that's from adding 4 plus 6. So to work out the pink arc, then that's going to be the angle. Now because it's on a straight line, if that's 50, then this angle here is going to be 130. So that's going to be 130 over 360 multiplied by 2 times pi times the radius of that arc, which is 4. And again, if I type that all into my calculator, so 130 over 360 multiplied by 2 times pi times 4, it gives me an answer of 26 over 9 pi. Now I could convert that into a decimal, which if I was to convert into a decimal, it would be 9.0757 blah blah blah. Now what is important is that because this isn't the final answer, I want to try and be as accurate as possible. So rather than entering 9.0757, I'm going to use 26 over 9 as a more accurate measurement of that arc. So the next thing I've then got to work out is the blue arc. So I just draw an arrow from that. So that's got 50 divided by 360 multiplied by 2 times pi. Now the radius of that arc is 6. So if I type that all into my calculator, so 50 over 360 times by 2 times by pi times by 6, it gives me an answer of 5 over 3 pi. So to work out the perimeter of this entire shape, then all I need to do, so P equals, and it's going to be, so starting at this length here and going in a clockwise direction, so that's going to be 26 over 9 pi plus 2 plus 5 over 3 pi plus 10. So what I'm going to do is just type that all into my calculator. So 26 over 9 pi plus 2 plus 5 over 3 pi plus 10, and that gives me an answer of 26.31, and that's going to be in centimeters, and that's to 2 decimal places, and there is my final answer. Now if I wanted to write this in terms of pi, then all I need to do is, looking at the two terms that involve pi, is you want to try and have a common denominator. So here I've got 26 over 9 pi plus, well, to change that into a 9 I times it by 3, so I've got 15 over 9 pi, which gives me a total of, that's going to be 41 over 9 pi. And then if I add the two numbers that I know, plus 12, put that in brackets, centimeters, and that there is my answer in terms of pi. Now, would I need to write it in terms of pi? Probably not. This might appear on the higher GCSE paper, but again, as long as you know the components and you're happy with it, then obviously it is definitely doable. So now let's have a look at some extension questions. Now these questions are incredibly popular both on a calculator and a non-calculator paper. Just remember that although the method is the same, the numbers will be a lot easier on the non-calculator paper than on a calculator paper. Now for this we're working out the shaded area. Now the general rule for shaded area questions, so the shaded area, and if I get a pen that we can actually read, so let's go for red. So the shaded area is always the big shape minus the small shape. Now in this particular question, my big shape is the big arc, the big sector. So here the big shape is one where the radius is 14. Now the angle theta for both of these two sectors are both 90. So here it's going to be 90 over 360 multiplied by pi times 14 squared. Now, again, the key thing to recognise that is a quarter. So that's a quarter times 14 squared, which is 196. Now I could then simplify that. And again, if I had to do this on, if it was a non-calculated paper, so I know where I've got 194 from. So let's just get rid of that and change that to a 6 over 4 pi. Now that does simplify. So 196 divided by 4 gives me 49 pi. So that there is the area of the big sector. So then if I then work out the small sector, so the small shape, then that's going to be 90 over 360 multiplied by pi times 10 squared, which is going to give me a quarter times pi times 100, which is 100 over 4 pi, which gives me 25 pi. Now to work out the shaded area, I just need to take away those two lengths, those two measurements together. So the shaded area is going to be equal to 49 pi minus 25 pi, which gives me an answer of 24 pi centimeters squared. So there's my answer in terms of pi, and you can see that I've not really used a calculator to work that out, but if I did want to work out the decimal answer to that, then the answer would simply be 75.4 centimeters squared, and that's to 1 decimal place, and there is my final answer. So moving on to this next question. So again here my big shape is the sector. So the big shape equals the sector. Now to work out the sector again, so I'm going to do theta over 360 times pi r squared. So substitute those numbers in, and again I can see that I've got a quarter here, so that's going to be 90 over 360 multiplied by pi times 9 squared. So that's going to be a quarter times pi times 81, which gives me 81 over 4 pi. And there is my answer in terms of pi of that big sector. Now the small shape is a triangle. Now to work out the area of a triangle, it's just base times height divided by 2. Now here the height is because it's both the radius, that's also going to be 9. So this is going to be 9 times 9 divided by 2, which gives me 81 over 2. So the shaded area is going to be 81 over 4 pi minus 81 over 2, and that's in centimetre squared. So that's the answer in terms of pi. But again, if I wanted to work that out as a decimal, then all I'd need to do is just simply type it into my calculator. So 81 over 4 pi minus 81 over 2, and that gives me an answer of 23.1 centimetre squared, and that's to 1 decimal place. So moving on to our next question here. So this, to work out the shaded area, it's the big shape, take away the smallest, so the shaded area. And here I've got a sector and I've got a square. So here it's going to be the square minus the sector. Now the area of the square is simply going to be 8 times 8, which is 64, and that's going to be centimetre squared. Now the area of the sector, and again, hopefully you know the formula by now, so it's going to be 90 over 360 multiplied by pi times 8 squared. So that's going to be 1/4 times pi times 64, which gives me the answer of 16 pi. So using these two measurements that I've just highlighted, that means that the shaded area in terms of pi is going to be 64 minus 16 pi, and that's going to be in centimetre squared. And that there is my answer in terms of pi, or I could simply type that into my calculator. So 64 minus 16 pi, and that gives me an answer of 13.7 centimetre squared, and that's to 1 decimal place. There's my final answer. So now I'm looking at this particular question. Now this one seems a little bit more complicated, but actually isn't. If I just simply look at this as one shape as it is, so here, and take this shape out, and just then draw a dashed line through here, then if I was to work out this area here, this question here is virtually exactly the same as the question that we attempted here. So what we need to do is, if I take that particular shape out, so what I'm left with is this, and the shaded area is 2 lots of that. So let's just write that down. So the shaded area equals 2 lots of this. Now we know that that's 20, and we know that it is a square. So to work out the area of this, what I need to do is the area of the sector minus the area of the triangle. Now to work out the area of the sector, that's going to be 1/4, or 90 over 360, times by 2. Actually, no, it's not. It's going to be times by pi times by 20 squared. And if I simplify that, that's going to be 1/4 times pi times 400, which equals 100 pi. Then I take away the area of the triangle, which is 20 times 20 divided by 2, which 20 over 20 is 400, divided by 2, take away, which gives me an answer of 200. So one of these shaded areas is going to be 100 pi take away 200. Now I need 2 of them, so I multiply that by 2, and so what I'm going to get is my answer in terms of pi is going to be 200 pi minus 400, and that's millimetre squared rather. Just get rid of that. Millimetre squared. Or as a decimal, if I type that in, I've got 200 pi minus 400, and that gives me an answer of 228.3 millimetre squared, and that's to 1 decimal place. Now we'll put some practice questions in the description below along with their answers so you can practice everything that's covered in this particular video.